Hello students. So today we are going to study chapter 1 of class 9th, number system. So in our number system, the first kind of numbers which we study are natural numbers. What are natural numbers? The numbers which start from 1. So in nature, if you count anything, you start from 1 only. Suppose you have some candies with you, and if somebody asks you how many candies do you have, so what you will do, you'll start counting them 1, 2, 3, 4, and so on. So in nature, if you count anything, you start from 1 only. So that is why the set of counting numbers is called natural numbers, and natural numbers are denoted by capital N if you write them in the short form. Then we study whole numbers. So what are whole numbers? Suppose if you have a chocolate with you and you have given that chocolate to your friend. So what is left with you? Nothing, right? So how will you represent that nothing in mathematics? So we represent that nothing by 0. So we need 0 also in our number system. So when we include 0 in the set of natural numbers, then they become whole numbers. So basically the numbers which start from 0, 0, 1, 2, 3 and so on. So they are whole numbers, and we denote them by capital W if we write them in the short form. Then we study integers. Now what are integers? So integer is a whole number that can be positive, negative or 0. Now what does that mean? So recently we studied whole numbers are the numbers which start from 0, 0, 1, 2, 3, 4 and so on. So they are included in integers. Now what is this negative? So negative of whole numbers are also included in integers. So negative of 1 is minus 1, negative of 2 is minus 2, negative of 3 is minus 3. Negative of 0 is 0 itself, because 0 is neither negative nor positive. So 0 will be neutral, right? So integers are the whole numbers and their negatives. So basically, most of the students, they think, when they think about integers, the first thing that comes in their mind is integers are negative numbers. So no, that is not true. Integers are not negative numbers. Integers are the whole numbers and their negatives. So in integers, we don't include all the negative numbers. That we need to take care. Suppose you have minus 2.5. So 2.5 is not a whole number, right? So minus 2.5 will not be an integer. So if a number is a whole number, then that is an integer, and its negative will also be an integer. So these two are integers, but this is not an integer, right? So this thing you need to take care. Now integers are denoted by capital Z if we write them in the short form. We don't denote integers by capital I, because with capital I we are going to represent some other numbers which you will study later. Z comes from a German word zahlen, which means to count. Alright. Then we study rational numbers. So numbers that can be expressed in the form of a upon b, where a and b are integers and b is not equal to 0. So what is this a upon b? A upon b is nothing but a fraction. So then all the numbers which can be written in the form of fractions, where numerator and denominator, a and b means numerator and denominator, they should be integers. Out of those integers also, denominator should not be equal to 0, right? So suppose you have a number 2 upon 5. So this is a rational number, right? Now 2 is also integer, 5 is also integer. So in the place of numerator and denominator, there should be integers but in denominator we can't have 0. So we can't have 2 upon 0 because division by 0 is not defined. So we never write 0 in the denominator, right? We never write 0 in the denominator, but 0 can be there in the numerator, because if 0 will be in the numerator, it means some other number is dividing 0, and if some other number is dividing 0, then we are going to get answer as 0 itself, right? So 0 can be in the numerator. Now all the whole numbers and all the integers, they are also rational, because we can write them in the form of fraction by putting 1 in the denominator, because if we put 1 in the denominator, it doesn't affect the number, right? So but the condition is a and b, means numerator and denominator should be integers if we have a fraction. So you can see some examples here: 2 upon 3, 6 upon 7, 1, 0. They all are rational numbers. Now you can see 2.5. This is also a rational. How? Because 2.5 can be written in the form of fractions like 25 upon 10. You have studied decimals in the previous classes. So this is how you can write decimals also in the form of fractions. So some decimals are also rational numbers. Now, rational numbers are denoted by capital Q if you want to write them in the short form. Again, we don't represent rational numbers by capital R, because by capital R we are going to represent some other numbers. And where does this Q comes from? So Q means quotient. Quotient means, quotient is what? Answer of division, right? So this is how we can understand rational numbers. Now we can understand it through the help of Venn diagram also. So you can see the circle of natural numbers, whole numbers, integers and rationals are there. The circle of natural is inside the circle of whole, because all the natural numbers are whole numbers also, but all whole numbers are not natural. Similarly, all whole numbers and all natural numbers, they are integers, because they are also included in integers. In integers we have 1, 2, 3, -1, -2 and 0. We can write so many numbers in integers. So all the whole numbers and natural numbers are also integers, but all integers are not whole or natural. Similarly, all the natural numbers, all the whole numbers, all the integers, they are included in rationals. So all these numbers are rational, but all rational are not integers, right? All rational are not whole, all rational are not natural, because in rational numbers we have some decimals also, which are not integer, whole or natural. We have some fractions also, right? Negative fraction, positive fractions, right? So all the integers are rational, but all rational are not integers. So we just saw some decimals are also rational. So let's see which decimals are rational, which decimals are not rational. So decimals are basically of two types, terminating and non-terminating. But non-terminating are further of two types, non-terminating repeating and non-terminating non-repeating. So first of all, let's see what are terminating decimals. Decimals that contain a finite number of digits. Finite number of digits means it doesn't have a repeating number or numbers which end up after a particular digit. So you can see here 36.5, 0.125, 4.5. We have all the examples ending with 5 here. So let's see some more examples. 2.8, 3.1, right? So these are also terminating decimals. 1.362, these are also terminating. They are ending after a particular digits. So all these numbers can be written in the form of fraction. If we remove their decimal, they will be written in the form of fraction. So they are rational. Now let's see non-terminating repeating decimals. So decimals that contain an infinite number of digits repeating in an order. So here we have infinite number of digits, but they all are repeating in an order. So you can see the example. Here 3 is repeating, it is endless. Here we have 7.689689 and so on. So it means 689 is repeating. So all these numbers we have got from rational numbers only. They can be written in the form of fraction. So how to write them in the form of fraction, that we are going to study in detail in the next video. So here, but I can tell you like how do we get them. Suppose we have 10 upon 3. So if you divide 10 by 3, you are going to get 3.333333. You will get endless 3 here. So here you have infinite 3's, right? So similarly we get these numbers through rational number only, because 10 upon 3 is a rational number, right? So non-terminating repeating decimals, they are also rational numbers. They can be written in the form of fraction. Now the third type, non-terminating, non-repeating decimals. So decimals that contain an infinite number of digits not repeating in an order. So here you can see 0.07692 So we don't know what we are going to get next because they are not in an order. Here 0.05882352. So numbers are repeating but they are not in an order, so we don't know what we are going to get next. So these numbers we don't get through fractions or rational number, so they are irrational. Now the question is, how do we get such numbers? So I'll just give you one example here. Suppose we have root 2. So if you expand it, if you take out its root, so you are going to get endless numbers, infinite number of digits in decimals, and they will not repeat in an order. So the numbers which are not perfect square, their root we will get as non-terminating, non-repeating decimals, and they are irrational because we can't write them in the form of fraction, which are in which numerator and denominator are integers. So here we come to know about one more type of numbers which are irrational. So let's study what are irrational numbers. So irrational numbers are the numbers that can't be expressed in the form of a upon b, where a and b are integers and b is not equal to 0. So numbers which can't be written in the form of fraction basically, but in those fraction where numerator and denominator are integers. So those fractions we can't write these numbers in those kind of fractions, right? So yeah, now you can see the example also. As we studied, just non-terminating, non-repeating decimals are the examples of irrational numbers. So this is an example of irrational number. Root 2 is also irrational because its expansion will be, decimal expansion will be non-terminating, non-repeating. Now here you can see we have pi also. Now how pi is irrational number? You must be thinking like pi we have generally used either 22 upon 7 or sometimes 3.14. So these are 22 upon 7 is a fraction. So how it is an irrational number? Because that these values 22 upon 7 or 3.14, they are not fixed value. They are the approximated value which we use to solve our questions, right? Because we can't solve our question with so many digits, infinite number of digits. and pi we generally get with the ratio of C upon D, circumference upon diameter, and their ratio is always changing. We haven't got a fixed ratio here, so that is why the value of pi also we get as non-terminating, non-repeating decimals. So that is why it is also considered as irrational numbers. Now, irrational numbers are denoted by capital I if you want to write them in the short form. Now, here we have important takeouts. Rational numbers have either terminating or non-terminating repeating decimal expansion. So, these two, terminating and non-terminating repeating, these two we get through rational numbers, or these two can be converted in the form of fractions. So they are rational. And irrational numbers, they have non-terminating, non-repeating decimal expansion. So we have some examples here. So root 3 is not a perfect square number. So its decimal expansion will be non-terminating, non-repeating. Minus root 5. So 5 is again not a perfect square number. So its decimal expansion will also be non-terminating, non-repeating. And as we have studied just, pi is an irrational number because its decimal expansion is also non-terminating, non-repeating. Now 2 upon 9, 1 upon 8 and minus 8 upon 11. These all are rational numbers. So their decimal expansion will be either terminating or non-terminating repeating. And as these three numbers are irrational, so their decimal expansion will be non-terminating, non-repeating. Then we study real numbers. So all these numbers, rational, irrational, they all are included, they all make real numbers. So real numbers consist of all the rational and irrational numbers. So all the example you can see 2, 0, minus 5, 2 upon 3, pi, 3.5, 0.2323. So all these numbers, all the rational and irrational, they are included in real numbers, and real numbers we represent through capital R. We can understand it through the help of Venn diagram. So you can see here natural numbers are included in whole numbers are included in integers are included in rational numbers. So all these integers, whole and natural are rational only. Then we studied irrational also, which are different than all these numbers. So, and then real numbers include all the rationals and irrationals. So in real numbers we study all the numbers which exist, which make sense. Alright, so all the real numbers can be represented on the number line. So you can see minus 7 upon 4, which is a rational number, and it is represented on this number line. Root 2 is also represented on number line between 1 and 2. Root 5 is also represented on number line between 2 and 3. Right? So how to represent these numbers on number line, we are going to study in details in the next videos. But here you can understand that all the real numbers can be represented on the number line, and there is a unique point for every real number on the number line. So I have a question for you all in the end. What is the decimal expansion of root 2? So its answer you can send in the comment box. So thank you, and if you like the video, please press on the like button and subscribe to the channel. Also, if you want, you can press on the bell icon also. So whenever we will put the next video, you will get the notification for that.